Hello everyone. In the previous video we studied about the capacitor filter circuit and also the special kind of diodes where we studied about the photodiode, we studied about the LED and also the photocoupler. Its working principles are studied. Now in this video we are going to study about the concept of voltage regulator. In the previous video, in the most probably in the starting two videos, we discussed about the voltage regulators. What is a voltage regulator? A voltage regulator is one which is going to maintain the constant output voltage for a range of input voltage. So it is going to act as it is going to work as a or it is going to work as a stabilizer. That is, it is going to give you a stabilized output when no matter at a set for a certain range of input voltages. Now, what is this all about? What is this voltage regulator? What are its features? The features are it is going to have it does not possess any external components to act as a voltage regulator. It is having an internal thermal shutdown protection, that is the whenever if when in the case of voltage regulators, when there is a high voltage we can expect the device to get heated up. Now there is a thermal shutdown protection provided to this which internally, and it has an internal short circuit current limit and output current in excess of 1 ampere, available in metal can, that is Kelvin, and that is metal can, and the plastic, that is T packages. It can withstand a maximum temperature of 150 degrees Celsius, and there is a dropout voltage of 2 to 3 volt, and it is going to have the ripple rejection of about 50 to 75 dB. Now this is what is our voltage regulator. When we look into our voltage regulator, you can see this is nothing but a three terminal. We call this as a three terminal voltage. We can look here. We have the three pins, that is input pin, one is input pin, ground pin and output pin. That is what is shown here. So your IC voltage regulator, whenever so far we've studied the voltage regulator concept in the Zener diode. Now we are into the IC concept where you have the three terminals here. One is ground, output and input. Now with this concept, let us move on to the series. What is the IC series? So we have the LM78XX series as our IC voltage regulator. So LM stands for the family of the 78XX series. Now in this LM78XX series, my XX, whatever the XX is there, this represents the voltage, output voltage. If suppose I take my LM7805 as my voltage regulator, my output voltage is now regulated to plus 5 volt. That is, it is going to stabilize the output voltage for 5 volt. Getting? So this is about your ICU as a voltage regulator. So no matter whatever might be, this XX can take any range of, that is it can be either 06, 7806, where the output voltage is now stabilized for 06. That is, my XX can take any value which represents the output voltage, stabilized output voltage. So that is why it is represented as 78XX series. It can take any series up to 24 volt, right? So up to 24 volt my IC voltage can stabilize. So if I write my 78XX as 24, then this is going to be, then we can say my IC 7824 is the one which is going to stabilize my output voltage for plus 24 volt, right? So XX can take any series of value. Now let us look into the block diagram of it. There is a block diagram shown here which is consisting of a pass transistor, a thermal shutdown and current limiting element, and then an amplifier, right? So when you look into this, This is nothing but an inverting amplifier, which you will study about this in the next coming videos. So this is, for the time being, let us assume this is an inverting amplifier, right? Now, whenever we go for the inverting amplifiers, always the input is given, that is the input voltage is given to the negative terminal. When you look into the positive terminal, you can see there is a voltage given here, which we call it as a reference voltage, that is Vref. Okay, that is nothing but Vref. Now, when you look into this, you have all these components along with the resistances R1 dash and R2 dash, right? Now, whenever, let us look into the working principle of this block diagram. The built-in reference voltage, that is Vref, wherever we have the ref, the built-in reference voltage Vref drives the non-inverting input of an amplifier, right? So this reference voltage is going to drive the non-inverting input of an amplifier, right? Now, wherever we have connected R1 dash and R2 dash, I can say my voltage is going to get divided across these two resistances. As a result, we call this as a voltage divider, okay? So a voltage divider consisting of this R1 dash and R2 dash samples the output, right? Samples the output voltage and returns it as a feedback to the inverting amplifier. Yes, getting the concept. So what is happening? My R1 dash and R2 dash are the two resistances which is going to act as a voltage divider, and it is going to sample the output voltage and return it back as a feedback voltage to the input of a high gain amplifier. Now, the output voltage is given by V out is equal to R1 dash plus R2 dash divided by R1 dash. So this is what is my output voltage across into Vref. So this is with respect to the voltage divider, we are calculating the output voltage. Once we get the output voltage, the reference voltage is equivalent, that is whatever the Vref we are taking, this is equal to the Zener diode and the Zener voltage, and the resistance is R1 dash and R2 dash, which we are taking it as a voltage divider, or these are the inbuilt resistances with the IC itself. Okay. Now, the LM78X6 series, right, includes a pass transistor that can hold, we can see the pass transistor there, which can handle 1 ampere of load current provided that adequate heat sinking is used. And one more component that we can see here is a thermal shutdown. As I told you, once there is if my voltage regulator is designed to allow or to regulate or to maintain the output voltage for plus 5 volt, even though if there is an excess amount of voltage flowing, it should stabilize it for 5 volt, right? So it should cut off to that particular voltage. Now if at all an excess amount of voltage is going to flow across, there is a heating up of the device, that is we call it as a thermal heating, right? Now in order to make the device protected from that thermal heating, we have the thermal shutdown concept here, which means that the chip will shut by itself. Which means that it is going to the chip is going to shut off by itself when the thermal temperature is going to become high. That is, it can withstand up to 175 degrees Celsius as it is discussed. Okay. Now, for your syllabus, we have 7805 AIC fixed IC voltage regulator. I already told you your XX can take any value, right? Your XX can take any value. Here, it has taken as 0.5. Now, what is the output voltage I can expect? It should get stabilized for plus 5 volt. Getting, so it should get stabilized for plus 5 volt. As it is discussed, we have three terminals. One is input, other one is output, and the third terminal is the ground part. So that is what is shown here. This is my unregulated input given to LM805. But what is the job of LM805? Even though the unregulated input is entering my LM7805, it should stabilize my output voltage to plus 5 volt. So this is my regulated output voltage that is coming across from LM7805 IC, right? Now when you look into this, you can see you have the two capacitors arranged here, C1 and C2. So we call this as input capacitor, which is which prevents the prevents oscillations, and output capacitor improves frequency responses, right? So when we look into this, we have pin 1 as my input, pin 2 as my output, and pin 3 as my ground, right? The LM7805 has an output voltage of plus 5 volt and a maximum load current we can withstand is 1 ampere, right? Now, the typical load regulation is 10 millivolt for a load current between 5 milliampere. So this is what is the this I mean date I mean this is what is the rejection rate, ripple rejection, line regulation, and all. Now once we look into this, the manufacturers recommend using the capacitor C for avoiding the oscillations. Why do we use this capacitor? Is the manufacturers recommend using capacitor for avoiding oscillations due to stray inductances of the connecting wires and bypass capacitor C2 to improve the transient response of this regulated output voltage. The typical values of this C1 and C2 are from zero point 0.1 microfarad to 1 microfarad. So in 78XX series has a dropout voltage of 2 to 3 volt depending upon the output voltage, which means an input voltage must be at least 2 to 3 volt, right? So what is going to happen here is it is going to improve the transient response of the regulated output voltage. My capacitors C1 and C2 are the one which is going to improve the transient response of the regulated output voltage. And also this is going to this is used because to avoid the oscillations that is produced due to the stray inductances of connecting wires and the bypass capacitor C2, right? So this is what is the concept on the fixed IC voltage regulator. So regulators are the one which is going to maintain the constant output voltage even then when there is a flow of unregulated voltage as its input, right? So no matter whatever my xx, that is 78xx, xx can take any range of value no matter. So plus at last we have 24 as its capacity. So if at all it is 7824, then the output voltage is getting regulated or stabilized to plus 24 volt. If at all it is 7812, then I can say my output voltage is getting regulated to plus 12 volt, no matter whatever might be my unregulated output. Unregulated output says if at all I'm using a 78, for instance, if I'm using here a 7805 IC. If at all my unregulated input voltage, that is suppose I have an input voltage of 8 volt, no matter whether input is 8 volt, my IC is going to stabilize my output to 5 volt. So finally I am getting the output as 5 volt at the output terminal or the output pin 2. Yes. So this is what is the concept behind IC voltage regulator. Hope this video is beneficial for you. Thank you for watching.